The wild, wild west is really almost what it will become as people move further and further from Earth. The material specs you're using here aren't accurate. A key for you to understand where your lack of knowledge may be. And if you don't have that clear, you're either going to be doing the wrong thing, or you're just kind of guessing, or possibly you're just wasting your time because it's totally unnecessary in the first place. Hello and welcome to Engineering Aerospace with me, Eric Kane. I'm an aerospace engineer with over 25 years of industry experience designing both aircraft and spacecraft systems, and I'm here to share my knowledge as well as the knowledge of others to help the next generation of engineers learn from our mistakes, accelerate their careers, and push the boundaries of technology for the future. I'm establishing this channel mostly to help those engineers that are kind of just entering the industry, but I'm hoping this will also be useful for folks throughout their career, as well as those that might be interested in just the general goings-on in the aerospace industry. But our focus is going to be on technical and soft skills that you can use day to day to help improve your performance in your job, get ahead in your career, and kind of become that go-to engineer that everybody's looking to get help from. So I'm hoping to establish kind of an ongoing series of different activities, different things that we can talk about and topics. We'll be talking about not just current news, but like I said, things like technical skills, practical skills that you can use, technical knowledge that not everybody is necessarily familiar with, looking at case studies from prior programs and designs, as well as potentially things like accident investigations and that sort of thing, so that you can kind of learn not to make those mistakes that others have, as well as to understand why were things designed the way they were in the past, so that you can understand whether or not maybe your new design should try something new, or perhaps it's not worth reinventing the wheel when someone's already done that many years before you. So I want to try and offer this as a resource for engineers to kind of improve their skills and capability as they move forward. I'll hopefully be bringing on some guests to talk about their experiences. We'll kind of go over some technical processes for doing certain things, talk about different subjects throughout the industry, and kind of see what the latest and greatest is in the technology and where things are moving in the industry. So I hope you guys will join me as I continue to grow this channel. I also do training and mentoring for young engineers, so if that's something you're interested in, you can always reach out to me. You can reach me on LinkedIn, or you can send me a note in this chat on the comments, and I'll reach out and try and see if we can talk some more. But until then, let's get into first topic for the series. So I wanted to talk through what I think is a very important practice for engineers to apply in basically everything they do, and that's why I'm bringing it up front. And that is what I would call the know your why. That is, why are you doing something? If anybody's familiar with a book by Simon Sinek, it's titled Start With Why. It's kind of along that vein, although his book is written from the perspective of business people trying to understand their mission and how they apply that to their brand. In this case, I'm actually talking about engineers knowing why they are making the selections that they are making. Why are they creating the features that they are creating? Why are they defining the requirements that they're defining? Almost everything you do in engineering needs to have some sort of why. And if you don't have that clear, you're either going to be doing the wrong thing, or you're just kind of guessing, or possibly you're just wasting your time because it's totally unnecessary in the first place. So I think this is a very important concept to bring to every aspect of engineering, especially when you're doing the design of a vehicle of some sort, and understand what it is you are doing every time you make a decision. So maybe some examples to help you kind of understand this concept is in the mechanical side of things, why might you, if you're designing a structure, use a rivet versus a screw? There's different applications for each of those. There's different performance characteristics of those. That's a decision you have to make and understand the why are you applying one versus the other. If you're on the electrical side, it may be why are you selecting a particular cable type? Let's say you're designing a radio system. Why would you pick one RF cable, one coax cable over another? There's dozens of different varieties available out there, and they all have different parameters, different performance capabilities and characteristics. And so understanding the why will really help you understand how to make the proper selection. I go up to some examples in the real world of a lot of the industry today has tried to move towards commercialization in space. You see a lot of small companies, in fact, a lot of companies kind of coming with the Silicon Valley mantra, coming with Silicon Valley money, and they're trying to take in this kind of rapid development with low-cost materials to get something into space, where the space industry has traditionally been a very long-term, very deliberate and expensive development process. And so there's certainly benefit that can be made by making systems cheaper, faster, and in this case, you're probably sacrificing some performance and reliability. But you have to balance that, right? You have to understand why is it that aerospace systems traditionally were so expensive? Well, the environment that those vehicles operate in is extremely harsh, and the rocket systems that were originally built to launch them into space were extremely expensive. Now, even today, when you start talking about SpaceX and Blue Origin, the launch costs have come down, but they are still not cheap, right? It's still far, far more expensive than, for example, flying cargo across the country in an airplane. So, it's not, negligible cost. And so you still do have to spend a significant amount of money to get these things into space. And so when you spend all that money to launch something, you want to have some expectation that those systems are going to function when they get up there. Now, of course, early in the industry, you had really expensive rockets, really expensive hardware, and that was because there was a lot of testing and design work done early on in the system development to make sure that when you spent that, say, 100, 200, $400 million to launch something into space, that it was going to work the first time, every time. Now, if you're spending $10,000 on a satellite, okay, maybe you're not as afraid to lose that hardware, but it still costs a lot to launch that in the first place. And so now you have to have a bunch of extra hardware, whether it's multiple satellites of the same thing. Well, if one of them fails, all of them could fail. So you need to make sure you're still spending some time and energy to, ensure your systems are going to function the way they're supposed to up front. If you're ride sharing with other satellites, that can reduce the cost, but you're still putting your own time and money into that system and throwing up into space. And those ride shares don't come along, super cheap all the time. And so what you find is, you have to have some level of confidence that your system's going to work in orbit. And so the trade-off starts to become, where is that breaking point, right? So if I just go grab, processor out of a cell phone or out of a desktop computer and make that the central processor for my new cheap satellite. Well, that's certainly an option, but we have to understand what is the environment and why did you select that particular piece of hardware over something else. So if you're a big company at like a Boeing or Lockheed, that probably isn't the type of hardware that you're going to be flying on your really expensive spacecraft. And why? Why is that? Well, it's because those pieces of hardware that they're going to select from legacy systems are designed and tested and proven to operate in the space environment. In particular, not just the hot and cold thermal environment in the vacuum of space, but radiation environments, right? And fault tolerance and manufacturing reliability. Again, there's a lot of screening and testing that is done on those systems, and that is why those systems are used in very high-risk environments. And so if you're going to take it on the cheap and go with a cheap COTS piece of hardware, there's no guarantees that those systems will work. And a lot of companies that were kind of in this commercial boom era of trying to develop rapid systems to go into low Earth orbit started to find that the systems worked for a while, but then as time went on, a lot of them began to fail. And so, that is a characteristic of the hardware that was selected. Yes, it's cheap, but that doesn't necessarily mean it's the right thing for the job. Now, in some cases it may be, right? If you're willing to accept that your hardware may only last a year in low Earth orbit, okay, that's a decision you make, but you need to understand the why you're making that decision. If you're going to fly something into geostationary orbit, fly something to the moon, the radiation environment is going to be far more harsh than it is in low Earth orbit, and that COTS hardware may not even survive the trip out there. So make sure you really understand why you're using any particular piece of hardware, why you're making selections that you are, so that you can have the confidence that you are making a reasonably good decision. Now, a lot of engineers, especially early in their career, are going to try to leverage existing design work, right? So you don't necessarily have all the experience that the others around you have, and so you want to leverage design work that they've done to make sure that you're kind of moving in the right direction, right? So when I came out of school, there was one project that I was asked to help with, and I went to another site and they had me designing some structural hardware. So I drew up the components the way I thought they should be, which was great. Dimensionally, everything was reasonable. And when the engineer that was overseeing my work started reviewing it, he said, "Hey, the material specs you're using here aren't accurate." Well, I hadn't even seen what the specs were before. I was just copying them off of a prior drawing. I didn't realize, what spec was going with which material and why I would want one over the other. And so I had to learn that and try to ask the questions and understand, well, why should I be particular on the alloy that I'm selecting of aluminum, right? Why should I use a 6061 versus a 2024 or 7050 or, particular tempers? What finishes should I use? Like all these material things, I didn't fully understand why I would select those. I saw them on other drawings, and so I just kind of copied the drawing. And so that's a key for you to understand where your lack of knowledge may be, is if you ask the question, why was this done this way, or why am I doing it this way, and you don't have a good answer, that's, I think, the first step that should tell you that you have to go ask that question to one of your senior engineers. Ask somebody around you that may have that knowledge and try to understand that, because as soon as you understand the why, now you know the application for that decision in the future. You're not just copying it and listening to what they say and say, go do this, and you go, okay, and you just put it on the paper. You need to understand why they're saying that that is the right choice for you in this particular application. So the next time the subject comes up, you now have a much better feel for what the right decision is. All right, so I hope that'll be useful for you. So the next time you come across a decision you have to make, you're doing a design of some sort, stop and ask yourself, why am I making this decision? And if you don't have the right answer, go ask a senior engineer and sort out what is the right decision to make there and why. So before we go, this first episode, I'm recording this in January of 2026. Thought I'd just talk briefly about what's going on in the industry. Hopefully we'll continue to do some kind of news segments. But at the moment, kind of interesting things going on in the world out there today. I wanted to talk briefly about the Artemis 2 flight. So hopefully folks are aware that the NASA is conducting the Artemis 2 mission to the moon. In this case, they're just going to fly around the moon, but they are flying in a very long orbit around the moon, which actually takes the astronaut crew further out from the Earth than anybody else has traveled before. So that'll actually be a unique record-breaking event, in addition to the fact that nobody's been there since the early 70s. So it's an exciting time. We're going to get to see more exploration, more development in the space world. That the other side of this is that there has been this kind of growing commercial industry. You've seen obviously SpaceX and Blue Origin, Amazon's building satellites. There's a bunch of companies trying to kind of commercialize space, which really has been commercial for quite some time, right? Communication satellites have been in orbit for a long time with commercial companies. So it's nothing new necessarily. I mean, there is some renewed interest in the industry, but still a large portion of the aerospace industry is driven by governments, right? So these are the NASAs and the DoD, the military programs out there of the world, and those still are the biggest driver for where programs are funded and why they're developed. I will say that just one trend that I've been seeing in the last year has been there's been a renewed interest in moving money more towards the defense side of things. So you're seeing more money spent on military programs. In the U.S., that's primarily, of course, the new U.S. Space Force, which came up several years ago, and so they're trying to establish themselves. But there's this growing interest in trying to establish the defense posture of the world in the space environment, right? So the space domain, as it's referred to by the military terminology. So while space has been primarily peaceful up to this point, and there are treaties that are in place to prevent militarization of space, it's very difficult to say that those are going to last the long term. Human nature is what it is. People will attempt to take advantage of each other in these other environments. If there are resources out there, there will be competition for them. As much as we try to keep those peaceful, I think in the long term, human nature is going to just take the best of it. And, we're going to have to do some things to protect ourselves and our assets and our interests in those new environments. This is no different than it was, when humans were first traveling out into the oceans, and when the Europeans started moving over towards the Americas and the so-called New World, that there were conflicts, right? And there were situations where, if you're going out into new places without any protection, that you're exposed. And the wild, wild west is really almost what it will become as people move further and further from Earth, because the rules and the systems that are in place here on Earth do not necessarily apply as much as we try to apply them out into the cosmos. They're limited by the power projection that we humans here on Earth have. So as you get further and further out from the Earth, the protection and the community that countries and nation states provide us starts to diminish. And so what I think we're going to see is that these nations, the US, China, Russia, India, the Europeans, all these different groups are going to attempt to maintain and protect their assets as they move out into the space environment. And so even though, we're not expecting to see huge changes in the next few years, I think you're seeing a trend towards that kind of future, right? Where just as it is here on Earth, the U.S. Navy and Coast Guard go protect shipping lanes throughout the world. The Space Force is intending to go protect the space environment from hostile actors out there. So it's going to be very akin to that. A lot of books on the subject would tell you that the military, the environment in space is very similar to what it is on the open oceans. Ships are only as well protected as they are in proximity to other defenses, right? So, it's an interesting development in the coming decades that I think space is just going to become a little more competitive, and you're going to see a lot more militarization of the space environment. Whether you agree with that or not, this is just my opinion as to where humanity is going, just based on our human nature. So, be interested to hear folks' comments and thoughts on that. But that's kind of where I'm seeing things go. But I am still really excited to see more peaceful uses of space, and the Artemis program is a big part of that. It's just very interesting to see the technology go out into place, and then the humans returning to the moon and continuing our exploration out there. So that's all I wanted to talk to you today, and I appreciate you for joining me on episode 1 of Engineering Aerospace. Hope to talk to you again soon, and we'll see you on the next one.